The problem is one of lack of generality. Jam is like the hardware. Jam is the machine. Joint accumulate machine. It's like the hardware, right? It's like a CPU. And then on top of that, you've got the operating system. Now, you don't need many operating systems, but you probably want a few that emphasize different elements of the machine. Actors / smart contracts that would run directly in core play. And let's be clear, core play at this point is speculation. There's not even a grey paper, let alone an implementation.
Rob recently released this idea of the Plaza.
Yeah.
What do you think about this?
The launch team wishes you good luck and Godspeed.
Space Monkeys blasting off with Gavin Wood. We're here in Singapore at the PBA, and it was very kind of him to sit down and do some Q&A about Jam. Questions from the community. Thanks for being here, Gavin.
Thanks for having me, Jay.
How's the Jam tour going?
It's pretty tiring, to be honest. That trip to the Americas was pretty full on, but yeah, it's good. The ideas are developing, the baking, and it's starting to mature.
Okay, and this is your last stop of this leg. You're gonna take a little rest, or?
Yeah, so there'll be a month or two rest, protocol development.
Okay.
Let's see how things go with some of the teams that are starting to write code.
Sure.
And a bit further out into autumn, like September, October, there'll be a few more lectures with the latter parts of the paper.
Because you're going to add on to the rest of this paper.
It's pretty much complete at the moment, but there are parts that probably need more detail. There are a few things that need to be added onto. They're more like, they're at slightly lower level. They're things like the network protocol, where it's like, it's useful to do, but it doesn't really form such an important part of the core protocol. But it's still important.
Well, look, I have some questions from the community here. I'll just play the fool. Actually, a role that comes kind of naturally to me. And First question, a little bit broad. How are you saying this now? What's the problem Jam's solving specifically?
It's a springboard for Polkadot. So the problem is one of lack of generality. The Parachains model is great for the product of Polkadot 1, but the world has moved on in those, 7-8 years, and it's important, to move with these realizations. And one of those realizations is that coherency is important, right? Having an environment where we can do synchronous composability is important. Now, there's only so far you can take this with the parachain mechanism, and allowing like XCM, while it does help chains systems like Polkadot interoperate, it's not a silver bullet. Synchronous composability is going to be, I think, an important factor in the success of any Web3 protocol. And so Jam is really providing a springboard to allow for the possibility of bringing about synchronous composability and a few other things that make interoperation between shards and possible, and make coherency, bring coherency to Polkadot, like, for example, accords.
So for a while there, we thought sharding was the answer to scaling, but it kind of presented new problems or potential problems down the road with this coherency.
Yeah, exactly. So sharding, I think, is still, what's the word? Sharding is not specifically the answer. So sharding is what we do in databases. We split a database amongst many shards, and they are largely independent. Now, the problem with sharding is it reduces coherency. Those shards are all very, it's all very well to do things within the shard. It's very difficult to do it between shards. And really, when we want to architect systems, if we already have a totally fixed idea about what the system's going to do, and it just so happens that it can fit within one shard, it's not a big problem. But when we want to build an ecosystem, and when we don't really know exactly which applications are going to be big, which are going to be important, which are going to be less important, and we don't know exactly how far they're going to grow, we can't make that decision up front. And therefore, having an environment that's synchronously composable but can also scale is really, really, in my mind, is a crucial factor in actually having an effective Web3 platform.
Okay, let's talk about Polkadot on Jam. One question that I've myself been waffling on, we have Jam, and then we have the Polkadot or the Parachain service. Now, does this look like the relay chain with all the parachains coming off it, or is each parachain going to be a petal?
There is one Polkadot 1 service, right?
Okay.
So Polkadot 1, Parachains, whatever you want to call it. There is one service that is the compatibility service for Polkadot 1.
Okay.
Right. So basically, one service alone implements the relay chain.
So the relay chain hangs around.
Well, no, but the concept of the relay chain, so what the relay chain provides, that hangs around.
Okay.
And that is implemented as a single service. There can be many more other services that do other things. But specifically for the point of securing parachains and facilitating communication between them, there will be one service.
So it's not like Polkadot is nested on top of Jam. The parachains actually interact with Jam directly.
Yes, but the parachains would still be elements inside of this service. So there would be Jam at the bottom layer, the services that Jam hosts above there. So it's like layer 2 if you want. On top of one of these services would be the Parachains service, the Polkadot 1 service. That would host its own parachains, right? That would host the parachains that we have at the moment. So we're now talking kind of layer 3, if you want to like build this thing up.
Okay.
And then if, for example, if a parachain hosted some off-chain smart contract system or whatever, then that would be kind of layer 4.
Right.
We kind of flip things around a bit. It used to be, we're still on the even numbers, but instead of the relay chain sort of being layer 0, parachains being layer 1, we're now saying, well, actually, we're going to insert the Jam chain underneath. And that we'll call it for the sake of argument, layer 1. That makes
we're not going to go negative 1.
No,
fine,
we can do if you want, but it's a bit.
Okay, fine. All right, let's keep going here. You've been using this visual of the petals and the flowers. Yesterday I saw oranges. Is this the same diagram? Okay, good. Each parachain is its own petal, potentially?
Each parachain right now is its own petal.
That's how we start, eh?
Right. That's how it begins. But the thing is, what we're doing is, and basically each parachain, these petals, they handle one parachain and only one parachain. So the model is that you never move data between the petals. They stay with a parachain unless you send an XCM or whatever. The whole point of Jam is to basically free up these petals to do other stuff. And what we mean by that is basically remove the concept of them being kind of fixed to a single parachain. But it's still possible if Moonbeam says, right, well, actually, we just want to keep renting a whole petal, and just have it to ourselves. That would be the same model as what we have now.
Okay, let's stick here. So this one's from Kian. He wants to talk about optimistic and ZK rollups as well as other possible services. What do you think about these other services developing? Is this something at the implementation level, or are services kind of built on top by other people, or how do those come along?
They could totally be built by other people. Now, the thing is, what a service gives you, it's a little bit like operating systems on hardware. So Jam is like the hardware. Jam is the machine. Join accumulate machine. It's like the hardware, right? It's like a CPU. And then on top of that, you've got the operating system. Now, you don't need many operating systems, but you probably want a few that emphasize different elements of the machine and try to provide an environment that make easy different sort of things. So you might have an operating system that is just there for multi-computer network processing, like a very heavily network-oriented operating system. You might have one that's like very UI-friendly, right? You might have one that's just bare bones, like totally bare minimum. But probably you're not going to have that many operating systems. What's more interesting is the applications that go on the operating system. So like one operating system will be the Polkadot 1 operating system, right? Parachains operating system. And that's going to have just parachains on it. There'll be the applications.
Sure.
The applications will sit on the parachains, but probably the parachains, we're going to see app chains. Like we've seen app chains. That seems to be what parachains are used for. Then on the next one, you're going to see something like, something I've been talking about for a while on the back burner, Core Play, right? This is basically the idea of an actor-based environment where actors can move between cores and get repartitioned up among cores. And this, we're going to see something much more like this heavily synchronously composable sort of smart contract kind of functionality.
So that's a different service.
That's a different service.
Anything happening on the Polkadot service, can they interact with what's happening in the Jam or the Play service?
I mean, there is nothing stopping them from doing this synchronous composability and kind of exchanging information when they're composed together.
Okay. Real quick before we move on, can you say anything about Elves?
So Elves is, ironically, Like, I mean, Elves deserved to be news about 4 years ago.
Okay.
Like 5 years
Never
ago.
heard it before.
When like Kusama launched.
Okay.
Because it was, maybe that's not quite right, but like, definitely 2 or 3 years ago. Because it's what secures Polkadot and Kusama. It's this underlying cynical rollup security mechanism, right?
Okay.
It's how we scale and still call ourselves secure. It's taken until now to actually have this paper written and ready for publication.
I see.
Which, you know, is...
Yeah, I think Alistair was telling us about it when he was on a few months ago.
Yeah.
He's like, now we're ready to go out and tell people what we've been doing for 4 years.
Yeah.
Okay.
I mean, that's the thing. But
That's Elves. Okay.
The ideas that are contained within Elves, and to a large extent, the sort of proofs and the security analysis and all of this has been around for quite a long time.
I see.
But, you know, it takes a while to write these things up.
Okay, next question. These work packages, can we define work packages real quick?
So work packages, if you like, they're a bit like blocks in traditional blockchain metaphors. So
Okay.
if we think of work items like transactions, and then we say, well, transactions are sort of bundled together into blocks, and then blocks kind of execute on a set of validator nodes. We kind of have the same thing with like work items and work packages. In some sense, the items are transactions and the packages are blocks. Mm-hmm. They're bundles of items. That's what it comes down to. Mm-hmm. Now, what stops a package from just being, you know, billions of items? It's a little bit like a block in a blockchain. There's a limited period of time of resources that a block can take to execute. That's why we have gas limits in Ethereum, for example. That's why we have weight limits in Polkadot and Substrate. And there is there's a gas limit in a work package. So it's basically a bunch of work to do. Now, the key thing why it's not a block is that work packages firstly execute in parallel. So there are 341 cores, mm-hmm. each one that manages a work packet, that executes a work package at the same time.
Okay. These are in the petals?
These are in the petals. 341 petals, 341 work packages. And then secondly, there is this middle of the flower, the reactor core, where the work packages kind of distill their output, and the output feeds into the reactor core to sort of react together. This you don't really have in a block because the transactions just also already execute inside of the reactor core, right? They already execute on chain. There's nothing else to react to. In Jam there is, because they mostly execute in the petal. Mm-hmm. And so you need this extra step of reacting together in the same environment.
Okay, so this gets us to a big question that I've heard from a few people here. Who's sequencing what's happening in the center of this reactor here? Where does that order come from?
There isn't actually an order.
Okay.
Services each see all of their quote-unquote transactions, in fact work items, mm-hmm. At the same time.
Across all the petals?
Across all the petals.
Okay.
As far as they're concerned, these things all were done at the same time. They just get given everything at once. It's up to them what order they want to put on these things. If they want to order it by, I don't know, hash, then they can order it by hash. If they just want to pick a random order, they can pick a random order. Like it's totally up to the service. Jam doesn't enforce any kind of sequencing. As for services that want to interact with each other, or like the comparative order between services see each other's prior state when they're interacting. So if a service wants to sort of inspect another service's state, it can totally do that. But the state that it sees is the state at the beginning of the block, not after anything has actually happened.
Okay.
Essentially, all of these services' reactions happen at exactly the same time. And if they want to look at each other, if there's any kind of causality, they will each see the prior state of themselves. If they want to send a message, they can. But again, messages get executed, quote unquote, at the same time.
Okay.
Everything happens simultaneously.
But if they want to message each other, isn't that like a block behind?
There's actually 2 phases in a block.
Okay.
So as it stands, this is one of the things that could foreseeably change over the course of the next few months. But at present in the grey paper, firstly, you have this sort of reactor happening. It's like all of the stuff from the petals comes in, reacts together, service moves forward. It may also transmit messages and funds out into other services. Immediately after then, there is another phase where those messages are all executed.
Okay.
and then the block ends. So actually, the messages or the funds are actually enacted in the same block, but they just happens to be at the end of the block.
So in the reactor, there's no sequencer necessary because all the cores understand what's happening at all times?
Well, nothing happens in a particular order. So indeed the services see all of the work items that they need to react together, they need to process at once.
Okay.
They're not fed in any specific order, in the same way that a transaction is fed into a smart contract, like in an order. It can't see all the transactions that are coming in the block at once, right? It gets the first one, then it gets the second one, and so on. It's not like that at all for services. For services, it's like, here are all of your quote-unquote transactions, being called work items, but in this entire block, figure it out.
Okay. Then, who builds the work packages?
Now, this is an interesting thing, and at present, Jam doesn't solve this problem.
Okay.
So Jam leaves this for a layer 2, right? It's up to layer 2 to work out what work it wants to do on the computer. In the same way that it's like, who decides how letters are pressed on the keyboard, or how what font should be displayed? It's like, it's not the point of the hardware. Or even the operating system necessarily to figure that out. It's more the application that should be figuring this stuff out.
Okay, and that layer doesn't need to be decentralized.
It may need to be decentralized. Now, the degree to which it should be decentralized is a question. Do we have like serious security issues? If there were a third of participants that are economically aligned, not nearly as serious as if we did on the base layer. That said, it may very well be that in forthcoming sort of version, 1.5 of Jam or 1.1 of Jam, that an additional facility is added to help with sequencing. But at present, it's not considered an important priority for the Jam protocol. The main reason is that I can imagine that there'll be layer 2s that will do their own sequencing, in the same way that Parachains tend to have their own collator networks that do their sequencing, right? And it hasn't been a problem in the Polkadot ecosystem thus far. And I think for something like CorePlay, where it's a single service with a single sequencer, we're probably going to have some pretty hefty domain-specific sequencing logic to do this. And I don't think that, I can't imagine how that could belong at the Jam level, because I think it's going to be super specific to CorePlay. And I don't see a big issue with basically have 10,000 different nodes who are helping with sequencing. It's a kind of a different problem to be solving compared to what Elves is solving.
Sure.
And Elves, it turns out, works fairly nicely with about 1,000 nodes. The kind of sequencing for CorePlay, it might work well with 1,000 nodes, but it might not work well at all with 1,000 nodes. It might need 100 nodes or 10,000 nodes, and it's a different problem, and therefore probably needs a different validator set.
Okay, so smart contracts directly on Jam, I think they're referring to CorePlay. That's where that would possibly happen.
Yeah.
Peter White asks, how will Ink be useful in Jam?
Like Ink as it stands, Ink would need to change somewhat. But as a starting point for a Rust-based domain-specific language for actors / smart contracts that would run directly in CorePlay, and let's be clear, CorePlay at this point is speculation. There's not even a grey paper, let alone an implementation.
Okay.
Then I think Ink could be useful in that regard.
Cool.
But, this is highly speculative, and I think we'll see over the next 12 months whether this speculation bears out.
This questioner probably has a galaxy brain. They ask, do you have cores accessing the same state at the same time? They want to know if race conditions is a concern with a decentralized data lake.
You wouldn't solve a race condition by using decentralized data lake. I don't think anyway. There might be some stuff that you could do there, I guess. But much more likely, you're going to use a synchronous vehicle inside of the reactor core, inside of the state, right? The system state, this super coherent synchronous state to do any kind of data racing management. The data lake is really there in order to provide large-scale data storage and potentially data transfer or data sort of kind of publication as a service might need to process data on multiple cores. But what is stored in the data lake is not guaranteed to be coherent across all cores all of the time. And the most obvious example of this would be when a core, a work package that executes on a core, puts some data in the data lake. On that validator, on that guarantor set, those 3 validators or those 2 validators that reported that work package, they will see that data. For them, the data lake will definitely contain that data. For others that are synchronized to that block, they will know that they should have that data. But if a work package arrives, it may take longer than a block or about a block to fetch that data, to discover what that data is. Even though they kind of know it's there, they may not actually have it to hand. And therefore, it could be slower on one core than on another. I mean, it would be slower for sure on any core other than the core that actually put the data into the data lake.
I see. Okay.
This isn't like an issue for consensus. It just means that the work package wouldn't be immediately executable. It would be eventually executable, like after a few seconds, once the nodes have had time to basically synchronize this data lake. And it's not that they would produce an invalid work report. It's like
just takes more time.
It would just mean that they couldn't produce a work report at all until they'd have chance to actually synchronize up on that data, and that lags a little bit behind the reporting of packages, like a few seconds. It's not an especially big deal, but what it means is if you have workloads where it relies on exporting data into the data lake and then importing it immediately afterwards in the next work package, you're probably going to want to rent out the same core. Okay. And then what we'll do as part of the protocol is try to ensure that if you are on the same core, this always works. Okay. What we can definitely do is say it will work 90% of the time.
And if it doesn't, it'll just take a few.
And if it doesn't, then you stall
blocks.
For a block.
Okay. All right, thanks. A few people asked, what's your favorite flavor of jam?
I mean, it kind of changes a little bit. If I'm feeling super indulgent, then maybe cherry. But on a regular day, strawberry, of course.
You're seeing jam as the preserve, not sort of like a band jamming.
No, the band jamming.
You see the band jamming more. Okay, all right. So we got to work that one in there too. A lot of people asked about. So Rob recently released this idea of the Plaza.
Yeah.
This is an evolution of Asset Hub. What do you think about this idea?
It seems to me to be a perfectly reasonable short-term tactic to mitigate some of the issues that we face with a lack of coherency across the network. And I think that's essentially what the point that Rob's trying to make with Plaza. I mean, and I don't see any of the points of action to be particularly controversial. I mean, it's like, bring smart contracts to Asset Hub, sure.
Also staking, you wanted to bring over and
out of the relay chain. I mean, that's already planned, and it's like there's no great staking doesn't need a huge amount of transaction throughput. Yeah. So I don't think it's a terrible idea, especially with async backing and like having lower than 6-second block times for this for Asset Hub to bring staking into Asset Hub.
Yeah, we actually had him on the show last week, and he was kind of making this point where, if there's no sort of forcing function to justify spreading out, the spreading out kind of creates more problems than solutions was his point.
It's certainly an easy point to make with Polkadot as it stands. You've got to be careful not to optimize for the present too much.
Sure.
And build a system that can actually scale to future needs. Without causing huge amounts of pain. This is what we did with Ethereum 1, right? And it's like we didn't optimize it for any kind of future needs. It was just like, there'll be Ethereum 2 in a year or so why bother? But of course, then you get stuck in a rut, and then people rely on this architecture, this synchronous composability, and before long, you don't have a path forward, right? You've walled yourself off.
Right.
Which is, I think, in large part the position that the Ethereum ecosystem is in at the moment. Essentially, that scaling is largely a patchwork quilt of parachain-like things. Different roll-up mechanisms, sure, but they are basically replicating parachains, but just not doing it like particularly uniformly.
Yeah, kind of a mess.
And very slowly.
Right.
As much as they need to use snarks, with a huge amount of underlying cost. So I do think that it's a bit of a false goal to sort of go after this one chain, purely synchronous, because, hey, it's easy and it's what people want. I think too far down that line and we end up sort of following the footsteps of networks like Solana, who are
it definitely seems really inspired, actually. Yeah. But maybe the thought is that Jam, we can kind of, gather energy, and then maybe Jam we can release after that. Maybe we work on UX and problems like that in this common place.
This is largely why I would support the idea.
Yeah. Yes. Okay.
Yeah. I just, I think it's important not to see it as a silver bullet.
Yeah. I think it's like a bridge. That's how I'm seeing it, at least.
I would say, if anything, a Band-Aid, but yeah.
Okay, Band-Aid, okay. Until Jam heals us?
Or it's, I mean, in some sense, yeah, I look at this as, okay, maybe Band-Aid is a bit cynical, but it's, as I say, it's a short to medium term means of consolidation of what Polkadot is bringing. And
a consolidation,
and actually,
that's a good way to put it.
And actually, hopefully delivering a product which is more palatable. Yeah. And can foster a sort of a greater, more connected ecosystem. But if it works well, then we're going to hit the limits quite fast, right? Cool. I mean, the current expectation is that we can maybe manage 2-second block times, so basically 3x. I think that delivers maybe 1,000 transactions per second, maybe a few more if we see some nice optimizations. It's not going to be what we need to get across this kind of million transactions a second now.
Yeah, no doubt. Okay, look, we have to get you going here. 2 quick questions. Yesterday, you got a great question from a student asking you about Runway, and you said, I think we have enough funds squirreled away to see this all through to fruition. Just wondering real quick if you could talk about what sort of resources do you think are needed to see Polkadot through to a point where it's this finally this global computer that's accessible to a wide group of people.
I mean, so Jam is the hardware, and I don't think the hardware isn't useful without an operating system. So we have to dedicate substantial amounts of resources to actually developing effective operating systems.
Sure.
If we're talking about delivering the underlying technology, and then I don't see an issue with what resources we have to play with. I don't think it's a question of resources. The question in my mind is more how this underlying technology is used, and ensuring that enough people are using it, playing with it, know how to use it, are inventive enough in its use, innovative enough, driven enough, and of course that the market that they're playing to is understands why this technology is useful to them as people. This is all stuff that I think is much harder, much more resource intensive, and has, to me, an unknown and uncertain amount of resource cost associated with it.
Got you.
So it's like, if the question is, do we have enough money to build this? It's like the answer is yes, for sure.
Okay.
If the question is, do we have enough money to get this to mainstream adoption in the world? Right. Then the answer is, who knows?
I see.
Like what? Show me the path to mainstream adoption, and I'll tell you if we have enough money.
Yeah. Okay. Awesome. Final question: are you happy with your Jam toaster?
It's not been delivered yet.
Okay, but I saw you got some final designs.
Yeah,
right?
yeah. I think this final design is actually an image of the unit.
Yeah. Okay.
They are building the units now. I think we're slated for the first deliveries to happen in the next month or so.
Great.
It will take a little while for the Polkadot Palace to be able to host them. I think the current estimate is end of September, where we'll have the actual data center area ready to go.
Wow.
But
you have to put in some new power lines, or what? Like
actually, the Palace is this mad building. It was built in the 50s to be like this billionaire's party place.
Okay.
And in the 50s, when you were doing a big, serious party place,
sure,
then it turns out that you put in a lot of power.
There you go.
So
that's awesome.
There's actually, it's got, I think, 300 kilowatts of power delivery. And I think the Jam toaster needs about 100. So we are well covered on electricity. But hopefully we'll be able to, we got like some solar panel installation that's going to be done in the next year or two. So hopefully that's going to offset what power we need as well.
Yeah, let's do it. Gavin, thanks for taking the time to talk to us today. We're going to start rolling out some video of your journey on this tour here. And of course, Key Pictures is ready to get a little documentary out, I believe, and then a big academic resource, because we want people to implement this paper, and we want them to know how to do it.
Yep.
Yeah. So thanks for coming on.
Thanks for having.